Okay, so I'm doing kind of a weird thing here. We did chapter 1, and I'm popping in a little bit of chapter 12, and then we'll go on with chapter 2. I'm doing that because this free program doesn't exactly fit into the way I want to do things, so I'm sort of tweaking it. I want to do a little bit of linear regression, just an intro right now, and then we'll do a whole bunch later. But I want you at this point just to see the beginnings of what's called linear regression. So this is chapter 12, just an intro. Okay, so here we are. We're chapter. What is this about? What if I measured? What if I went around the whole schools, got like a survey of 100 people, and I asked them, how many hours do you spend studying? Hours on homework, let's say. Or just keep it simple. Hours on homework, or I'll go back. I guess there's more than just homework. I'll just say studying. Hours studying. And how many, sorry, I keep changing my mind here. It's hours studying, so you study how many hours, and what's your GPA? And, I'd go around and ask people how many hours. Now, of course, this is really rough estimate because there's, like you all are probably night students. You probably have one class, maybe two, compared to a full-time student. So anyway, so there's problems, but in general, let's just, what we would see is we would see somebody who studies more hours. I'm just going to make up some numbers here. This will be per week. Week per week. I should have written that down. So weekly hours of studying. So the person that maybe averages 30 hours a week studying, full-time student, I guess, maybe their GPA is 3.2. And somebody else that studies only 20 hours, their GPA is 2.6. And somebody else that only studies 10 hours a week, their GPA is only 1.8. Somebody else that does 18 hours a week, their GPA is 2.0. Somebody else that does 47, their GPA is 3.6. Blah, 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 blah. I'm just making up data. If we went around and asked people, and of course there's differences, and this isn't quite that simple, but in general, we would probably find this idea as we went around, that if we asked people how many hours they study per week, more hours of studying means higher GPA. Probably. In general, of course, there's exceptions and people only taking one class and other things like that. But in general, and then if I did a graph of hours of studying on the x-axis here, weekly, and on the vertical axis, I put GPA. This would be 1.0, 2.0, 3.0, 4.0, 3.0, 2.0. Sorry if you can, I'm a little scribbly in my writing. 3.0 like that. This is GPA on this axis. Hours of studying weekly on the x-axis. And I started putting those dots on the axis. And I'll go across with the hours of studying. Here, I'll just go per week 10, 20, 30, 40, 10 hours per week, 20 hours per week, 30 hours per week, 40 hours per week. Let's try putting, remember like XY points? You guys tracking with me? Sorry, my graph's kind of all messed up here. I'm trying to be a little neater. So can we put some XY points on the graph? So what I mean is, like this is an XY point. Remember from your algebra days, doing XY points on a graph? Were those good days? Were those the best days of your life? Those algebra days? X is 30, Y is 3.2. So that means over at 30, go over here to 30, and go up to 3.2. There's a dot right there. That dot represents the over 30 up 3.2 piece of information. Tracking with me? Somebody, excuse me, one person studies 30 hours per week, and their GPA currently is 3.2. That's what that one dot represents. Somebody that studied 30 hours and has a GPA of 3.2. And then there's this next person. Can you put that one on the graph? Can we all do that real quick? I think this would be... let's do the next one. So over 20, up 2.6. So over 20, there you go, over 20, up here to 2.6. Where's that? Well, here's 2.0, here's 3.0. So where's 2.6? Well, a little more than halfway. Just eyeball it the best you can. Is that making sense? Would it help if I put the lines in? Maybe that would help. Like, you know what I mean? Like this is the 1.0 line, 2.0 line, 3.0 line, 4.0 line, and this is the 10 hours of homework. I'll get rid of this right here. And 20 hours of homework, and 30 hours of homework, and 40 hours of homework. Does that help a little bit? Sorry, my drawing is not the best. So, let's make it sense. So again, let's locate the points. This one is over 30, up 3.2. The next one is over 20, up 2.6. About right there, huh? Over 20, up 2.6. That good? See how I'm finding that? It's over 20, and it's up just a little more than halfway. Between 2.0 and 3.0, it's a little more than halfway. It's 2.6 GPA. Next dot, over 10, up 18. Over 10, up 18. 1.8, sorry, not 18, 1.8, about right there. Over 10, up 1.8. Almost to 2. Over 10, up 1.8. Then over 18, up 2.0. Now, where's 18? Well, I don't know, it's eyeball. It's almost to 20, huh? 18 is almost to 20, and go up to 2.0. So that would be about right there. Does that look right? So that one, that's the over 18 hours a week, up 2.0, dot, and then last one, 47. That was kind of off my screen, huh? 47 up 3.6. Somehow it'd be way over there about, wouldn't it? So about right there is the over 47. That person just studies a lot. Over 47, up 3.6. Okay. Okay, we good with those dots? Is making sense? That we just did is called a scatter plot. It's just a scattering of dots. We just made a scatter plot. We're going to do it with our calculator. If you have it tonight, in a few minutes, we'll do it. I think if I remember this section, we'll do something with our calculator. So we'll just do it automatically. It's kind of nice. With your calculator, you just type these numbers in, and bang, hit a button, and it just makes it for you automatically. Super convenient. But it's good to see it by hand, too. So scatter plot, just a scattering of dots. Now, why? Who cares? Why are we scattering these dots? What do we care? What we're looking for is a relationship, a linear relationship. Remember what stats is all about? Two things. Describing data, we're pretty much almost done with that. There's not much of that in this course. Looking at tables and describing things. And then making decisions. Inferential statistics is the most important part of statistics. So we're looking here and we're saying, is there a relationship here? Let me get rid of this. Almost looks like a dot down there. It's not. Is there a relationship there? Do those dots look like they're in some kind of a pattern? Sort of. I mean, not exact for sure. But is there some kind of close pattern? Do those dots fit a graph? Do they fit a straight line? Looks pretty close. Could I fit a line through them that kind of goes through the middle of those dots? Sort of like that. That line right there that I just put through there is the line that fits best through the middle of those dots. That's called the best fit regression line. We're gonna just begin here, and then in about a month, no, 2 months, we'll do a whole bunch with this. So I just want you to get the big idea right now, because it's an important idea in statistics. That's why I want the intro. So this section will be super easy. It's just going to ask you a lot of true-false questions, not a lot of calculation, just the feel. I just want you to feel what we're generally talking about. It looks like these dots, which means hours of studying weekly and GPA, have a linear relationship, doesn't it? You study more, your GPA goes up. Probably in general. Of course, there's always exceptions. You're taking crazy hard classes and stuff. But in general, probably true, right? If we went all over campus, asking everybody their hours of studying their GPA, we would probably find a somewhat linear relationship, wouldn't we? Meaning that these two things are connected. More hours of studying, higher GPA. As you go to the right, the line goes up. It's a positive slope line, isn't it? If the line doesn't go down. And we'll get some of those. In fact, what if I come over here real quick and I did, hey, how about if I do, I don't know what, TV hours or internet or whatever, and GPA. Or maybe work, right? If you have too much work, that's what gets in the way a lot of times, right? So what if I did, let me just change to work. The more you have to work, sometimes it's hard. I tried taking a couple classes after I was like an adult, and I had a couple of kids and a job. I would show up at exams having not studied. I didn't do that back when I was, I was a good student when I was terrible in high school, but when I was in college, I was serious. But I remember, so I know some of you guys are in that boat. That's why I say I've been there. It's crazy when you got a job and kids and a life, and some stinking teacher telling you to study. I was taking classes in the Bay Area. I would arrive, and there'd be like an exam that night. I was taking Greek. That's hard too. The original language of the New Testament in the Bible. I was trying to learn it, and I would show up, and I'd pull up, and I go, "There's a test in 15 minutes." I haven't even studied. This is craziness, and I think I don't got time to study. I got these kids and this job. Anyway, so that makes it hard, huh? So what we'd probably find, if hours of work go up, so I'll just make up some data here. If you're working like 30 hours a week, maybe your GPA goes down to 2.8. If you're working 40 hours a week, it might go down to 2.6. If you only have to work 10 hours a week, maybe you can have a higher GPA. Of course, there's exceptions and blah, 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 blah. But what we would find in general is as hours of work per week go up, like 10 hours of work during the week, or 20, or 30, or 40, probably, if you're only doing 10, you're up at 3.6. In general, we would find the dots go down like this, huh? That there's probably a negative. So there's a negative linear relationship, probably, between hours of work and GPA. I know that was true in my life. Make sense? So we're talking about how two variables relate to each other. How does hours of work compare to GPA? Probably a negative relationship, right? More hours of work, GPA drops. Y'all see that? GPA, 1.0, 2.0, 3.0, 4.0, right? See how the dots are going down to the right? Negative relationship. Whereas over here, positive. This is a positive linear relationship because it is hours of studying and GPA. As you do more hours of studying, your GPA goes up, probably in general. So anyway, the scatter plot, which is the dots, and then the line that fits through the middle of those dots best, called the regression line. We have something we calculate called the linear, let me get it up here, the linear coefficient R. I'll write it down here where there's some room. R is the correlation, it's the linear correlation coefficient. Big name there. R is what we're interested in. R is the linear correlation coefficient. We're going to just let the calculator crank them out for us when we get there. I'm just giving you the big picture right now. We're going to get to the details in a bit. But mainly, this is just big picture here. Mainly, we'll get to the details in a couple months. But in a couple months, the calculator will crank out numbers for us, R numbers. And what that number will, and I'll give you examples of it, that R will tell you how tight those dots fit in a line. How much of a line really are they? I mean, not perfect, right? Those are not in a perfect line, but they're pretty close. How close exactly? Well, R is something statisticians crank out to tell them how much of a linear relationship there really is between two variables like hours of studying and GPA or hours of work in GPA. Positive and negative relationships. All right, so there's your flyby, the overview. Let's go in now to the specific questions. Right. Okay, so here we go. In fact, I should probably, before we even do this problem, I should just give you the general game plan. If you have a bunch of dots that fit in a perfectly straight line going up, that's R 1.0. If you have a bunch of dots that fit in a perfect straight line going down, that's negative 1.0. If you have a bunch of dots that fit pretty straight going up, that would be something like about 0.8 or so. Basically, R, the linear correlation coefficient, is between -1 and positive. The lowest it'll go is -1. The highest it'll go is +1. If you have a bunch of dots, let me come down here. If you have a bunch of dots that fit kind of going down, but not perfectly, that would probably be R is -0.8. Maybe 0.7. Those look a little looser, don't they? 0.7, I'll just say. What if you have a bunch of dots that don't look like anything? Does that look like a straight line? No way. Your R is going to be basically 0, or close to it. Maybe 0.1 or -0.1. Doesn't matter. It's basically 0. Which means, so this means no linear relationship. So do you get the big idea of the R thing? So that's what we'll learn to calculate. Our calculator will just give us the numbers. We won't have to do it. It's a big pain. Computers are made for doing it. But what you want to be able to do in reading statistical data is know what R really means. If it's close to 1, if it's positive, the line's going up. If it's negative, the line's going down. If it's close to 1, if it's right 1.0 exactly, it's a perfect line. Or -1, perfect line. If it's close, like 0.8 or -0.7, then it's pretty close to a line going up or a line going down for negative. Does that make sense? So when R is close to +1 or -1, it's very close to a line going up or down. As it gets more towards the middle, more towards 0, there's basically no linear relationship. That's what R tells us. So let's go to the homework now. Here's question number 1. Here's the different R values. Can you see those? Let me make them a little bit bigger for you. So A is -0.86. B is 0.93. C is 0.36. And D is -0.46. Okay. So let's answer the question. So this first one, they want us to look at these dots and decide if it's A, B, C, or D. It's kind of hard to... Let me jump to the second one. I like the second one better. Look at this one with me for a minute. What does that look like? Does it look like a line going up or down? Yeah, pretty much like a line like that, huh? A line going up to the right, we mean, right? Yeah, let me be clear on that. We always mean as you go to the right. Because, if you're standing on this line, you could go up or down, right? You go to the right, you go up, you go left, you go down. We always mean as you go to the right. As you go to the right, that line's going up, so it's a positive. Now, there's two positive numbers. There's this one, and there's this one. Those are both positive. The other two are negative. So those are both positive. Which one do you think that one is? Yeah, it's this one, isn't it? This is the 0.93. Because it's a pretty tight fit. I mean, it's got a little off, but that's a pretty good fit. That's an upward, pretty tight line. Now let's go back, say, to this one. What is that? Does that look? It's hard to tell if it's even going up or down. I would guess. What would you guess? Yeah, I would guess it's kind of like that. Not very tight though. Not very linear. Right? There's not a lot of strong evidence that these dots are really lining up. That's where we're going from, pretty soon. It's all about evidence. How strong is the evidence? Those dots do not seem to be lining up very much like a line. Little bit. Not very much. So what number do you think is for those dots? Yeah, this one, huh? Negative point, because it's down, but it's not going to be the 0.86. There's one of those other, this one. Yeah, there it is right there on our screen. This one is down much tighter. Huh. So that one's the negative 0.86, isn't it? That one's down much tighter. Everybody see that? So when the numbers are tighter, it's closer to 1.0 or negative 1.0. When the dots are tighter. When the dots are looser, when the scatter plot is more loose, it's closer to 0. And then one more. Well, there's that one again, which is the negative 0.86. Is that what it was? Yeah. And then what's this last one? Yeah, whatever's left, huh? It looks like it's kind of going up. I don't know. It's just a big smattering. It would be the last answer, the 0.36. So that looks like 0.36 positive. So it is sort of up, but very loose, very close to 0. No linear relation. Not strong. And later we'll say that's not strong evidence of a linear relationship. Make sense on that? So this is what people do in the real world. If they have a couple variables, they're studying something. They're saying, hey, I wonder if, this quality is related to that quality. Well, they'll get a bunch of data, and they'll have a computer do a scatter plot. And then they'll calculate R to try to figure it out. Okay, question 2. The linear correlation coefficient between the explanatory variable x and the response variable is R. Negative 0.83. So don't worry about all that. Blah, 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 blah. All that matters is they said R is negative 0.83. That's all we care about from those words. The slope of the line, the regression line, that's the line that fits through the middle, the regression line, is what? Negative, positive, or you don't know? Negative, yeah. We already talked about that, right? If the R is negative, the line's going down. If the R is positive, the line's going up. Just like that. Let's look at number 3. Here, I'll move it up in a second. Let's read what we got so far. Here are the scatter plots for 2 sets of bivariate data. Bivariate, that's a fancy word. It just means 2 variables. Bi, like bicycle, two tires, 2 variables. X and Y. Grades and hours of studying. Scatter plot, bivariate data, two variables with the same response variable. The first compares the variables X and Y. The second compares the variables W and Y. Okay. Okay. Which explanatory variable has a stronger relationship? So basically, which one's a tighter line? That one, clearly. And they said the first is X and Y, the second is W and Y. So the first one. It's a tighter line. There's more of a linear relationship there. You can tell just by looking, right? All right, so question number 4. All right, so basically they want me to put the dots on the graph. So the first one is going to be the point 10, 10. Is that making sense? So I played with it one time, like a month ago or something, or 2 or 3 weeks ago. And it gives you like a pencil thing, right? Yeah. And it has you do like dots. So it's a free program, but it's fairly good though. So see what you can do. It's a dot. So where's 10, 10 going to be? This is 10 right here, right between 8 and 12. So right there is 10, 10. See how I found that? Right? Because it's over 10, halfway between 8 and 12, up 10, halfway between 8 and 12. That's 10, 10. That dot is the 10, 10 dot. We're seeing if there's a relationship between first quiz and second quiz. Scores people got in the first and second quiz. Next one, 11, 8, right? 11, 8. So put that dot on the graph. Over 11, that'd be just right there. Up 8, it's going to be right about there. 11.8. So you got to do your best to find those locations and then put all the dots on the graph. And when you're done, it has you sketch a line for best fit. How does it have you sketch the line? I can't remember now. What does it do? Are we good with that? So again, let me just, we didn't see any of that. Whoops, I got to switch over, don't I? Yeah, so what I basically did, is found some dots and then put the line through there. And then at the very end, you got to use the line. What are they saying? 21. My example now is 21. Let's go over to 21. Go up and go over and find, looks like a height of 22. So that's what you got to do, right? Put down the dots with the pencil. So use this thing to put the dots. And then use the line maker tool to make the line. Right? And then once you got the line, go to what they're saying, 21. That looks like 21. Go up to the line that you put in and go over and find out your height, 22. So that means a quiz score of 21 predicts a quiz 2 score of 22. There's a relationship there. Like hours of studying predicts a grade, or quiz 1 score predicts a quiz 2 score, etc. My 15-year-old son, almost 16, just said to me that when he went to the doctor predicted he would be 6'2" or 6'1" or 6'2". How do they do that? How are they doing that? Linear relationship. They're using statistics, foot size, basically, predicting height.
Probably genetics, I would assume too.
Maybe other things too. But a lot of it is they're using statistics. A linear relationship, one thing predicting the other. Right? Foot size predicting height, hours studying predicting quiz scores. All right. So question number 5. If the correlation coefficient is negative, what does this mean? So if the correlation coefficient, the R, is negative, what does this mean? The regression line, is there just one answer? Problem. The regression line can be used for prediction? I'm just going to read them all. There is a strong correlation. The calculation was done wrong. The slope is slope's negative. Yeah, that's the only thing you can say for sure. If the R is negative, the slope is negative. Yeah, on we go. Number 6. The correlation, R, is a number between what and what? -1 and +1. Yep, -1 and 1. R is a number between -1 and +1. Number 7. If it's 0, then there's no relationship between the variables. Yeah, true. Technically, they should have said no linear relationship, but I won't be picky. On we go. I know what they meant. Question 8. If the equation of the regression line that relates hours per week spent in the tutoring lab to GPA is blank blank, then the best fit for GPA, who never go to the tutoring lab, is 2.1. All right, fit line. So here's question 8. So it says, hey, if you've got some equation, let me write it. Y equals 2.1 plus 0.28x. And they say, what is this? When you have these word problems like this, you don't need all the words, but you do need to know what the variables are. So just cut out all the words, blah, 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 blah. But what's x? Hours per week in the tutoring lab. That's hours in tutoring. And what is y? GPA. So this is a relation. You don't really even need the rest of the words. This is a relationship between GPA and hours in tutoring. Meaning you could plug in how many hours were spent in tutoring, multiply by 0.28, add 2.1, and you'll get what your GPA should be. It's probably not that simple, but that's what they want us to believe, at least, on this problem. Does that make sense? So what are they saying then? The best prediction of the GPA of a student who never goes, I get the wrong English there, to the tutoring center is 2.1. Is that true? What if somebody never goes to tutoring? What does this formula predict will be their GPA? If they never go to tutoring, what's their hours of tutoring? 0. X is 0. Right? So if you plug in a 0 there, you're going to get 2.1 plus 0.28 times 0, right? This is multiplied by x, which is just 0. So y is 2.1. Yeah, true. It is 2.1. That formula would predict a GPA of 2.1 for somebody never going to tutoring. Does that make sense what I'm doing? What if the person spent 10 hours a week tutoring? Then I would plug in a 10 here, right here. This would become 10, and I would calculate. Makes sense? How that works? Get the idea? Those two variables are connected by that equation. That's what an equation is. Do you think about equations that way? It'll help you to more and more think about equations that way. An equation is a relationship between x and y. It's a friendship between x and y and how they relate to each other. X takes on a certain value, that forces y to respond, right? So if x was 10, if somebody plugged in 10 for x, say, I'm going to go 10 hours a week to tutoring. What will my GPA turn out to be? Well, you could plug in a 10, hit the buttons on your calculator, multiply by 0.28, add this, and you'd find out the GPA it would predict for you. See how that works? That's what we're going to be doing in about 2 months. We'll find those equations that relate for real-life data. Okay, question 9. If the equation of the regression line for the day's high temp x and the mean number of robberies is boom, then on average, okay, so we have this equation, y equals 0.3x plus 20. Now what, you got to know what the variables are. What's it saying? What's x? So what's x on that one?
Day's high temperature.
Day's high temp, right? So x is the temp, the high temp. And what's y?
Number of robberies committed that day.
Number of robberies. Is there a relationship between the temperature and the number of robberies?
No.
I don't know. I mean, certainly not a causation one. But anyway, there could be a relationship. Who knows? Anyway, this we'll get into that stuff later. But this is saying they've got this equation here. So if this equation was true, if this was the true relationship between temperature outside and or the high temp of the day, this is the high temp for the day. So that would mean in summertime when the temperature's higher, there's more robberies, right? Or are there less? How do you know? Let me ask you, does that line have a positive or negative slope? Is that equation a line going up or a line going down? Do you remember from your algebra days? It's okay if you don't. I'm not assuming you know a bunch of algebra. I'm going to remind you of everything needed. No need to be alarmed. We assume nothing, and we'll take you from there. So, it's right here is the slope. So let me write that out for you. If the number next to x is positive, the line goes up to the right. If the number next to x is negative, then the line goes down to the right. It's always to the right that we're talking about. So this is a positive. I mean, there's no sign there, which means positive, right? Positive 0.3x. So that means it's a line going up. That's the slope. The number next, remember y equals mx plus b? You may or may not remember that from your algebra days. The m is the slope. The number next to x is the slope. So the other number doesn't matter, I mean, as far as telling you up or down. It matters for other things, but as far as whether that line goes up or that line goes down, it's always what's next to x. So that's positive. That line's going up. Okay, so what? That means as the temp, remember temp is on the x-axis, right? Temp is the x. As temp goes up, robberies is the y-axis. Robberies go up. They go up together. So higher temp, days with higher temp tend to be days with greater robberies? Yeah, they do. What would explain that? Maybe this is the state of Minnesota or something. And most of the year it's too frozen outside to do anything, rob or do anything. And only on the higher temp days. Who knows? So let's try that one. So the equation is y is negative 0.7x plus 42. What is x? Hours of cycling. And what is y? Hours spent working. So what kind of relationship do they have, positive or negative? Yeah, that negative right there. So what does that mean? When they have a negative relation, that means if you did a graph, the line would go down, meaning, and the x-axis is cycling, and this is work. So as you do more cycling, that's less work. You have less time to work. That's what that means, right? As you go to the right, as the cycling numbers go from 10 hours a week to 20 hours a week to 30 hours a week, the work hours go down, 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 don't they? Is that what they said? What did they say? As the number of cycling hours increase, the number of work hours decrease. True? True. Negative relationship. Okay, number 11. Researcher found the correlation between age of death and number of cigarettes smoked per day to be negative 0.95. So the R is negative 0.95. That's the correlation coefficient, R. Based on this information, the researcher can justly conclude that smoking causes early death, because that's a relationship between age of death. Age. So if you had an axis here, let me draw the axis. Age of death and number of cigarettes. So, and it's a negative relationship. So, is it true then? Can justly conclude that smoking causes early death? The answer is no. False. Why? Right? As age of death goes up, you want to live longer, you got to smoke less. So if you smoke more, if you're up here at the higher cigarette numbers, right? This is the y-axis is the number of cigarettes. If you're at the higher cigarette number, you're at the lower age of death number. Doesn't that line show that? Yes, but what? What was the big phrase? Tell me that you heard something from me last week. Please encourage my heart as a teacher.
Does not mean causation.
Yes, thank you. Association does not necessarily imply causation. Right? Remember the bottled water and the cancer, Boy Scouts and criminals? Those have linear relationships too. That's what I was basically showing you. Those have, but the bottled water's not causing cancer, and the Boy Scouts aren't causing more criminal behavior. Right? Two things can be related, even linearly related, but not, there's the key word. If they took that word out, it would be true. If they just said, hey, smoking less seems to be associated with longer life. Yeah, that's true. It does seem to be associated. But to say smoking less causes, or causation, that we can't say necessarily. Not from this data. Now, it's been proven that it does, because they've done controlled studies. Right? That's what you got to do to prove causation. Remember, did you catch that last week? To prove causation, you've got to do a controlled study. This is just an observational study. So association does not imply necessarily causation. Just because two things are connected doesn't mean one's causing the other, like we saw last week, right? Causation can only be determined by a controlled study, right? Controlled study. Where you have one group that has the cigarettes, one group that doesn't, everything else is the same, you measure other things, right? Controlled study. So we talked about that. We better move on. Number 12. If the equation of least squares regression line, blah, 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 then the correlation cannot be less than 0. Is that true? Cannot be less than 0. How do you know? Well, first off, what is less? They're saying cannot be less than 0. What is a number less than 0? What do we call that? Negative. They're saying it cannot be negative. In other words, it must be positive. That's what they're saying in fancy talk. They're saying it cannot be less than 0, meaning it cannot be negative, it must be positive. Right? Y'all with me? They're saying it must be positive. Is that true? Is this equation positive? Yeah, right there. Positive number next to x. Positive slope. True. We good there? That makes sense?